Mr. Pelton. This is Algebra 2, Chapter 5, Section 3, Radical Functions. We're going to be doing the graphing of them. So you basically have even or odd roots when graphing them. So we'll do an even root, the basic square root first. So any function that contains a radical is basically a radical function. So you can make a table of values if you choose to do so, but don't just pick any values. Don't just pick like -2, -1, 0, 1, 2, as if you're an Algebra 1 student. Think a minute how silly that is. One, can you do square roots of negatives that are on the graph? No, those are imaginary. Those aren't going to work out. Square root of 0 is easy and 1's easy. What's square root of 2? That's a decimal, right? So we don't want to do decimals. We want to do nice whole numbers. So A, pick things that work. B, pick things that are easy. You should know from basic fourth grade and up what the easy square roots are. So 0, 1, 4, 9, 16, so on and so forth are easy. So 0, 1, 2, 3, 4, so on and so forth are the easy square roots. So at 0, we're at 0, 1, we're at 1, 1, 2, 3, 4, we're at 2, 9, we're at 3. Obviously, then the rest won't work because they're not on the graph, but that's fine. All we know is it goes in this direction forever. So as far as domain, 0 is the least input and it goes to infinity. You can plug in 0, so you need the bracket there. Range, 0 to infinity also, because it starts at 0 and goes up forever. And what you'll find is all even roots have this domain and range for the parent, right? Because the parent is the simplest form. So this is the parent of the square root. So whether you make that 2, 4, 6, or 8, it does not matter. Okay, it does not matter what number you put here for the index. As long as it's even, the graph always looks like this. It has this domain and range for the parent. If you do odd, we'll do the parent of the odd, so third root, make a table again. So again, two things. A, pick things you can do. B, pick things that are easy. Well, it's an odd root, so I can do both positives and negatives. The easy ones are 0, 1, -1. Think about what is the next easiest uh, third root that you can do. What can be broken up into three parts? Well, 8 and -8. So the third root of -8 is -2. That's -1, 0, 1, and 2. So make the graph of that. So at -8, we're at -2, -1, -1, 0, 0, 1, 1, and 8, 2. So it looks kind of like the even root, except it goes in both directions. So even roots go in one direction, odd roots are going in both directions, kind of making this pinwheel. So they go forever left and forever right. And the range might not be also apparent, but it does go up and down, but slowly. But it does generally go towards positive and negative infinity. So there are no domain restrictions on odd roots. Okay, so let's go to page 2 and think about graphing roots, doing them a little bit quicker. So we have a quarter in the first one and a -2 and a -3 in the second one. So this goes back for doing transformations. If you don't remember transformations, go back to chapters 1, 2, and 3. Look at the list. I've also attached the list of transformations on page 4. Adding and subtracting moves you upwards and downwards. Shifting, which is translation. If it's in the inside, okay, that's left and right. Keep in mind that it's counterintuitive. Positive means left and negative means right if it's in the inside. However, up and down, positive means up, negative means down. Remember, the inside affects X, the outside affects Y, but it's counterintuitive on the inside. So reflections, outside affects Y. So if I change my Y value, I reflect it over the X. And if I put the negative in the inside, I changed my X value because it's in the inside, therefore I reflect it over Y. Okay, multiplying on the outside is scaling, which is stretching and shrinking. And likewise, in the inside is stretching and shrinking. However, it's counterintuitive on the inside, so be careful on those values. All right, let's go back and try the actual problems. That was just a little review from chapters 1 through 3. Okay, so what does the 1/4 do? It's in the inside. It affects X. So that's horizontal. Okay, So it's really dividing by 4, so it's counterintuitive. So it's actually stretching horizontally, okay, because it's counterintuitive. If it was on the outside, it'd be um, shrinking, but it would be also vertical. So what does this look like? It's an even root, so it's going to be the one swoosh, but it's just going to be a stretch, so it just goes up higher. That's all it happens. Instead of being down lower, it just goes up a little bit higher because it's a stretch. Does that change the domain? No, it's still 0 to infinity, and this is still 0 to infinity for the range. Because essentially at the end of the day, 1/4 x must be greater than or equal to 0. So if I times each side by 4, x must be greater than or equal to 4. Nothing changed with that. So what you're gonna notice is stretching and shrinking does not affect anything for domain and range. So -3 is in the inside, that affects x, is counterintuitive, so it shifts it or translates it to the right. Okay. The 2 on the outside since on the outside it's y, so that's vertical. Multiplying by 2 is a stretch because outside is straightforward. Oops. Eraser. Come on. And the negative on the outside affects y. So if you change your y value, you flipped over the x-axis. So reflect on the y-axis. So reflecting over the y-axis happens first. Remember, you do have an order of operations, right? 1, 2, 3, 4, which is also the order of transformations, right? Can't quite get in there. So what do you have first? You have your horizontal translation first, your vertical translation last. You have your scaling second, which is stretching and shrinking, and then your reflecting happens third. So we have a horizontal first, which is going 3 to the right. Okay. So you would think, based on that, that it would go like this since it's in even root. However, it reflects on the y-axis. Okay. I'm sorry, reflects on the x-axis. That is incorrect because essentially that's a negative right there on the outside, so it changes y. So go over the x-axis. That's going to make it go like this when you reflect over. Okay. And the 2 stretching it just stretches it more. So that's not going to change anything because stretching and shrinking is the one thing that does not change your domain and range. So as a result, my domain goes from 3 to infinity, and my range goes for the high of 0 and goes down to negative infinity for range. Okay, let's try 2 more. Okay, now we have some odd roots. We have third root. So the -2 is a shift downwards. Since it's on the outside, it affects y, so vertically down. So it moves down 2. So it just goes down 2. And so you have your basic cube root graph or odd root graph. So the domain and range does not change because there are no restrictions on the odds. All right, next one. This is in the inside, so it affects x. So it's a horizontal shift, and this one's going to be left because it's counterintuitive whenever it's in the inside. And as a reflection on it's on the outside, so it affects y, so it changes your y, so reflected on the x axis. So we shift left first because that's a horizontal translation, and that happens second. So we shift left 2. So normally you'd be like this, but since we reflected over the x-axis, now we're going to be like this. But that's again, we're doing sketches according to the directions. There's no domain restrictions here for odd roots. They go in all directions because you can do both positive and negative odd roots. Okay, pause the video, try the student problem. Next page. Okay, so if you look at this even root or square root, we have a 4 in the inside. So in the inside is x, so that's horizontal. And multiplying by 4 you would think is a stretch, but since it's in the inside, it's counterintuitive, so that's a shrink. and we have a negative in the inside, which is a reflection. If it's in the inside affects x, so if you change your x value, you went from one side to the other, you reflect it on the y-axis, right? Okay, so let's take a second here. So our typical square root looks like this, right? But we shrunk it, so it's just going to look like this, which is not really a big deal. Then reflected on the y-axis, we're just really going the other direction. So the reality is this is our graph, right? Let's see. Okay, so we shrunk it. Yeah, we did that. That comes first. Ah, I lost my marker. That's the problem. Trying to figure out what's going on there. Oh, I'm on the eraser. That's what it is. So that came first. That came second. All right, so our domains, the highest I can be is 0, and it goes to negative infinity. In my range, it's the lowest I can be is 0 and goes to positive infinity, but we can be 0, so that's going to be a box. Okay. All right, next one, domain and range. So we have, it's in the inside, so that changes x. That's a horizontal translation or shift left since it's +2. It's counterintuitive. And this is on the outside, so that's vertical since it affects y. Vertical stretch. So typically you'd be like this, right? For a square root or even root. So the translation horizontal comes first. That must move left too. So you'd be right there. But then as a stretch, you just kind of stretch it more. But that doesn't really change anything as far as domain and range. None of the stretching and shrinking does. So our new domain, it's -2 is our lowest, and it goes up to positive infinity. In range, the lowest is 0, and goes up to positive infinity. All right, two more. Okay. We have a +4 on the outside, which affects y. So that's a vertical translation up. So you just move up 4, shift up 4. You have a negative on the outside, which affects y. So let's see. So that's a reflection because it's a negative. So if you change your y value, you went over the x-axis. Okay. So if it's a third root, you typically look like this. So that happens first, the reflection, and then vertically moving up is last. That's the fourth step in the translations. So reflect on the x-axis. So if we do that, it's going to go this way. And then we have to go up 2 though. 1, 2. So that is going to be our new graph. So we can erase the other pieces we don't really need. Okay. But again, there is no we didn't want to sketch here, which we did, and there's no domain restrictions here. So that didn't change. Okay, and then the last one, we have a -4 on the inside. So that's translate right, since inside is x, right? It's horizontal. And it's counterintuitive on the inside. So typically my graph looks like this, but I have to move right 4. 1, 2, 3, 4. So now it's my new graph. That one doesn't count anymore. But again, there was no domain restriction for this one. That is the end of part 1.